Hello, and welcome to this webinar, From Fresh to Frozen in 3 Minutes Flat, Unlocking the Secrets to Temperature Control. This event, brought to you by the National Provisioner, is sponsored by Air Products and Chemicals Incorporated. I'm Fred Wilkinson, editor of the National Provisioner, and I'll be your moderator today. Thanks for joining us. Our presenters today are Tony Vacaro, Foods Industry Manager, and Emile Klein, Foods Market Strategy Manager at Air Products and Chemicals Incorporated. Before we get started, please take a moment to scroll down and explore the webinar console. You can download handouts, click on the speaker images to view their bios, and submit your questions or comments anytime using the Q&A box. We'll address as many as possible at the end. Today's webinar is being recorded and will be archived on www.provisioneronline.com. And now I'm pleased to turn it over to today's presenters, Tony Vacaro and Emile Klein.
Thank you, Fred, and welcome everyone for joining us. Today, we're talking about something we hear over and over again from food processors, and that is how to control temperature quickly, safely, and consistently, especially as operations get more and more complex. My name is Emile Klein, and I am Foods Marketing Manager at Air Products, and I've been spending a lot of time recently talking to food processors about the challenges that they're facing. Joining me today is my colleague, Tony Vacaro.
Thanks for the introduction, and thanks to everyone for joining. Before we get started, I did just want to thank National Provisioner for the opportunity to speak with you all here today. This is a great platform, a lot of really informative content, and we certainly appreciate the opportunity to talk about the work that we're doing here at Air Products. As Fred mentioned, if you guys have any questions throughout the webinar, please feel free to submit them in the chat. So my role at Air Products is strictly focused on the food industry. I get involved with sales, new product development, marketing efforts, new equipment deployments. And for our customers, we're able to provide critical gas supply for operations like freezing and modified atmospheric packaging. And we also design and build and deploy large-scale industrial food processing machinery that utilizes our gases, like cryogenic tunnel and batch freezers. So with all that said, I'll turn it back over to you, Emily. Where do you want to start?
Yeah, so we're just going to jump right in. And so one of the biggest themes that we're hearing is regulatory pressures around cooling cooked products. So especially with FSIS guidelines, they're calling for rapid cooling. So essentially, we're taking just really, really hot product, we're taking it and we're trying to cool it down, typically to 70 to 80 degrees pretty quickly. And then within 5 hours or less, we're trying to bring that temperature down to around 40 degrees. So from a processor standpoint, Tony, that can be really stressful. What options do processors have to meet these guidelines?
Yeah, it's a great question. So for those unfamiliar, FSIS, the term she used, refers to Food Safety and Inspection Service. So this is a group dedicated to food safety, of course, and they set the guidelines for ensuring that cooked products get through that food temperature danger zone fast enough to prevent bacterial growth. So as you alluded to, these cooling targets can be very challenging for processors to meet consistently, especially as their plant demand and their throughput increases. So this is a great use case for cryogenic equipment. So cryogenic equipment, or flash freezers, utilize cryogenic fluids such as liquid nitrogen or carbon dioxide. So these refrigerants are incredibly cold. So for example, liquid nitrogen is minus 320 degrees Fahrenheit. So just very, very cold. Equipment such as cabinet freezers or inline tunnel and spiral freezers can utilize these refrigerants to operate down at temperatures as cold as minus 200 degrees Fahrenheit. So at just a few minutes of dwell time in this really cold environment, processors can really jumpstart their cooling process, and they can save hours when compared to ambient or other refrigerated cooling methods. So I always like to give examples. So to give an example from my past, we did have a large meat processor that we were working with, and they were really struggling to hit their cooling curves on some very large cooked beef brisket pieces. So this was a company that we worked with to deploy a tunnel freezer, an MP Plus freezer. It's the fastest cooling tunnel freezer variant that we offer at Air Products, just meaning that it has the highest heat transfer. It can do the most amount of cooling in the shortest footprint. So there's a picture of it here on the screen. And in just 5 minutes of dwell inside this machine, we were able to really rapidly drop the temperature of that beef. They were able to go from 130 degrees Fahrenheit to below 40 in under 2 hours just by adding this simple inline step. So we're showing a graph here, and you can see the cooling curves. The red line was their cooling time and temperature without our equipment, and the blue line is the cooling curve with our equipment. So as you can see, that little bit of time, just 5 minutes at cryogenic temperatures, really cuts down on their overall chilling time when compared to just traditional refrigerated cooling.
So, Tony, I see the pictures there of the chicken breast there at the slide. Can you expand on what we're looking at there?
Yeah, sure. So what we're looking at here is the cross section of just a frozen chicken breast. So the same machine that can be used to jumpstart the freezing process for large pieces of meat can also be utilized for rapid crust freezing on very high throughput lines. So this MP Plus freezer would also be a great piece of equipment to utilize for that. So this particular graphic, we see two pictures, the two pieces of chicken. The picture on the left is a piece of chicken frozen through this MP Plus freezer we're talking about, our highest heat transfer machine. And then the picture on the right is the result of a piece of chicken frozen through our standard tunnel freezer at the same exact dwell time and the same exact temperature as the first photo. So what I think is really neat about this graphic is it really demonstrates the benefit of having that higher heat transfer machine, right? So this could be used as a replacement, for example, for customers that are currently tote chilling or operating some type of a slicing line that really requires product to be crust frozen prior to that slicing operation.
No, and it's really neat to see, you know, the difference between the different freezing techniques. So another term I do hear a lot in the industry is IQF, and I think there might be some use of IQF and maybe not the right terminology. Can you expand on what IQF is and what capabilities do we have with IQF equipment?
Yeah, no problem. So IQF is definitely the term in the industry, albeit to your point, I do feel like it often does get misused. So IQF stands for individually quick frozen. So this is really the result of a freezing process where food processors can freeze individual pieces of something. So yeah, perfect on this slide, right? You were showing berries or shrimp or chicken nuggets. When we want individual pieces of something coming out frozen, those would be IQF. So the MP Plus freezer that we were just talking about is just a cryogenic inline flash freezer. It's not the type of equipment that we would most likely deploy if we were looking to set up a processor with an IQF line. So if a processor was looking to achieve IQF product, there are three different types of machines that we would utilize to do so. So those would be a vibratory belt freezer, where we're actually taking a standard inline tunnel freezer, but we're jostling the belt, getting that product to lift up as it freezes, facilitating that IQF nature. We could also use an incline flighted belt freezer. So this would be a series of belts that have an incline and then a drop, and we're using those drops to facilitate breaking apart any clumps and achieve that IQF nature. And then the third and final method would be probably the most traditional, which is a cryogenic immersion freezer. So each of these three different types of machines has different strengths depending on the product that the processor is looking to freeze. But that said, I would say the most common historically would be an immersion freezer. So I didn't talk about it, but an immersion freezer works by dropping product directly into a bath of liquid nitrogen. So that's a minus 320 degree bath of liquid nitrogen. The second that product comes in contact with it, it's going to immediately crust freeze the outer layer. It's going to facilitate 100% IQF, very little chance for marriages. That's multiple pieces stuck together. And it's great for customers that are looking for very rapid crust freezing, very high throughput. And it does have the added benefit of really preserving the shape and the moisture and the surface quality of that product. And actually, it just so happens we at our products, we are currently working on the development of a brand new immersion tunnel freezer. So we do have a prototype that we're ready to deploy. So if anyone on the webinar is interested, please feel free to reach out afterwards.
Thank you. Thanks for explaining that, and obviously very interesting looking at all the different equipment options that you have. So I think if I'm a food processor and I'm listening, I might be interested. Obviously, these machines seem very complex. I would like to see if you can break down just what some of the installation requirements are to install a system like this.
Yeah, great question. So it's actually a lot more simple, I think, than people expect. I always say a typical cryogenic system really has four main subcomponents. It'd be a bulk storage tank that sits outside the facility. So you can see a picture here. It's a large white silo that sits outside. We're going to have piping that's going to be used to transport the fluid from that tank to the processing equipment inside the building. Then you're going to have whatever processing or freezing equipment gets installed inside the building. So that could be a cabinet freezer, it could be a tunnel freezer, a spiral freezer. And then the fourth thing you're going to have is an exhaust system or a ventilation system. And that's used to remove the vaporized cryogenic liquid after it's been utilized and we've used the refrigeration from it. So cryogenic systems are a little different than traditional mechanical systems. They're what I like to say is a once and done type spray. So after that cryogen is utilized, it gets vaporized, and then we exhaust it outside of the building and release it back into the atmosphere. So that's really the core of it. From a footprint standpoint, we're often talking about an outdoor pad requirement for a solo tank installation of about 15 by 15 feet. And then inside the facility, our freezers and our equipment come in a variety of different shapes and sizes. So really just going to depend on what gets deployed and what throughput requirements our customer has.
So just to clarify, I guess this doesn't mean that it's automatically a massive facility expansion that you need to do.
No. Yep, that's correct. So cryogenics are often chosen specifically because they fit traditionally where mechanical systems can't due to their size. When I reflect back in the last few years of our customer installs, I would say the most common length tunnel freezer we've deployed would either be a 2 or a 3 module machine. So that would be 20 to 30 feet long, roughly. And machines like that can process up to about 3,000 pounds an hour or more, depending on the product and the heat load.
Awesome. No, it's interesting to see, I guess, just with like a 20-foot footprint, how much throughput you really can put through these machines. So thanks for answering that. All right, so next question here. So I think a lot of food processors might be interested in cryogenics, but I think when you hear liquid nitrogen, you can automatically think like, oh gosh, that's going to be expensive. So can you give me a realistic view of what more or less the cost is like for some of these systems?
Yeah, no problem. So, our business model, I feel, is great for processors looking to get started who maybe don't have access to a lot of upfront capital. So our equipment, both inside the building and outside the building, typically don't require any upfront capital. It's really just a monthly operating fee that you'd pay. The big variable, of course, would be how much of that cryogenic gas, either liquid nitrogen or liquid CO2, are you using on a monthly basis. Now, that being said, if you're using gas, you're hopefully at that point freezing product and therefore generating revenue. So you're able to offset those costs. So, ultimately, we really try to make it, fast and cheap and easy for our customers to get up and running. Now, that said, there are some upfront capital costs that would be for site prep work and some of the ancillary components that we talked about before. So duct work, piping, some of the electrical requirements. So there certainly is an upfront capital piece. And given that required investment, I always do stress that it's important for prospective customers to really validate the operation before deciding to move forward.
Yeah, and that definitely is something that we hear about a lot. We hear, prospects that are interested and they like what they're hearing, but they want to validate the equipment and the quality before investing. So, can you explain maybe some of the options that a prospect has to validate your system?
Yes. So this is a critical step, the validation, right? So whenever we're talking with a prospective customer, we highly encourage them to come and visit our world headquarters in Allentown, Pennsylvania. So we have a state-of-the-art food lab in Allentown, and here we can test a customer's product on the full-scale production equipment that they might see in their own plant. And that ability to test on true production equipment, to me, is invaluable for our prospective customers. Right? They get to really see and feel the machine. They can familiarize themselves with the controls, the touchscreen, the doors, the buttons, right? It just makes a whole lot more sense when you can really get your hands on it. And then the customer will bring in, samples. We'll be able to run different freezing time and temperature tests with the equipment. We can use those testing results to really determine what size equipment will be best for your production line. We can take those samples and actually ship them back to the customer site, to their QA team. If they want to validate the quality benefits that you get from flash freezing. And then most importantly, our team will calculate exactly how much heat we're removing through calorimetry. And we can actually use that data to then generate an estimated cost to freeze. So how much incremental cost are we adding to the cost stack to freeze with cryogenics? And then once you have that, right, you've got a rough sense of monthly spend. And that's really just the ultimate critical information, I think, for a customer to have to really feel educated enough to make that final decision on whether or not to move forward.
Wow, no, that makes it very easy, and obviously a very important part is validating. So thank you for going over that. So I'm going to jump to the next question here. Naturally, when people and when prospects hear about liquid nitrogen, you think extremely cold. A lot of safety questions, come in mind. So is this process safe, or how, can you expand on the safety of it all?
Yeah, absolutely. So to answer your question, yes, these systems are safe, but they definitely need to be designed and operated correctly, right? I think that's key. Safety is paramount at Air Products. It's something that we speak a lot about in our quarterly earnings calls, and just internally as we speak in all of our meetings, we typically lead with safety. Before we start up a customer at any site with a cryogenic system, we go over a few different safety considerations, things like making sure they have a very clearly defined safety procedure. So the same way that you would drill for something like a fire alarm, we highly encourage customers to walk through and have a plan of what they would do in the event of an emergency with our system. We always ensure that operators are wearing the appropriate PPE, discussing what is the appropriate PPE, right? Ensuring that there are atmospheric monitors, something like an oxygen monitor, electrically interlocked to the machine and always powered on, right? That's key. And we wanted to ensure that operators are adequately trained, and that they not only are trained, but they have the right material to train the next folks that are hired at the company without needing Air Products to return. And then we're always listening, right? We're always listening to our customers and evolving for their needs. So for instance, again, in the interest of an example, we had a customer recently that was interested in having an automated means to stop liquid from flowing into their building in the event of an emergency. So our engineering team was able to develop a control panel system to help a company do just that. And it's been, incredibly successful for us, and we're using it at other customers. So just to elaborate on this design, it's a very simple control panel that's able to take a variety of input signals. So that could be from the plant fire alarm system, or atmospheric monitors, or e-stop buttons strategically located around the plant. We can tie all those signals in and then use that to control the signal for an automated valve located outside the building downstream of the tank. So it's a pretty unique system, and it certainly enhances the safety at any site. And then we can even tie this into our smart technology system, where we could provide a real-time alert or a text message to someone in management if we see this event occur.
Well, that's actually a perfect segue to my next question here, because a common theme and a common question that's raised is around the food processors' desire to be more data-driven right now and control their efficiency and their operations through data management. So what's Air Products doing in this space?
Yeah, so smart technology, that's the name of our solution, exactly for what you just described. Right. So smart technology is the Air Products data collection and called visibility platform. So in the food space specifically, all of the machinery that Air Products is designing today is all going to be what I would call smart technology equipped, meaning that it's going to have the necessary hardware installed in the machine's control panel to connect it to our Air Products smart technology network. So processors can use our smart technology system to monitor things like the current machine temperature, what the set point is, how much cryogen they're using, so how much liquid CO2 or liquid nitrogen they're consuming on a daily basis, overall system performance, mechanical performance, things like motor speed and frequency and power draw. All that stuff can be data logged and then viewable historically through the website. So once we've got that hardware and once we have data flowing into our system, the possibilities of what we can do with that data are limitless, right? We can issue text and email alerts if we see things that are incorrect with the system. We can send daily reports about the previous production day and how it worked and how well the system ran. So this is a very, very unique piece of technology, and it's really enhanced the way our customers are approaching their operation. So some of the recent success stories have shown that our customers can reduce their gas consumption by paying attention to this data. They can optimize their temperature control, the way the valve is controlling. They can reduce their unwanted downtime. The way they can do that is the customer can interact with our engineering team, and our engineering team can dial into the system and very quickly, understand and diagnose what issues the machine is seeing or having, and making sure we can get the customer back up and running as quickly as possible. So it's a very valuable system, I'd say, to processors out there.
Yeah, and I think so. Smart gets thrown around a lot these days. I think we're in the world of artificial intelligence, and we hear, Industry 4.0, we hear IoT. So can you expand on, are these just buzzwords, or what's the real value that processors can see?
For sure, right? They are the key buzzwords today. So I think to answer your question, the real value is really usability. So our platform is really easy to use. Instead of guessing or reacting to bad data, this system gives our customers very clear and actionable information. So whether that's in the form of texts or emails, the customer can choose. Our customers are telling us that they really like the traceability aspect. They like the historical data aspect. The maintenance staffs at these companies are thrilled with it because if they can minimize their downtime, that's immediate revenue generating tools for them. So, just the ability to talk with an engineer at Air Products and have them truly understand what the issue is because they can see all the inputs into that machine. It's incredible. If you're a plant manager, you can use the data to really track uptime, production schedules, what is your cost and gas usage. So I think there's a lot of benefit to a lot of different parties within a processor's operation. And I'll be clear, the system doesn't automatically make these changes, but it does highlight, I think, to the different teams locally what they need to focus on.
Yeah, no, I mean, it does sound like that there is a lot of value, obviously, in seeing your data and this data collection. So thanks for going over that. So I do want to leave some time for questions. So if you had to sum it up, what's the biggest takeaway that food processors should, take with them if they're listening today?
Yeah. So I guess number one takeaway would be Air Products we're a first-in-class cryogenic gas supplier. We pride ourselves on our safety performance and our on-time deliveries. But aside from gas supply, I want food processors to know that we also design and build what I call first-class freezing systems. These are incredibly efficient and cost-effective machines that are easy to operate. They're easy to maintain. They're cleanable. I really stand behind our equipment, and I value what our team has been able to create and iterate upon over the years. And other than that, I would simply say that we have a very dedicated engineering and field-based CT team. That's really just whole focus of these teams is really helping our customers, achieve their goals and run efficiently. I love our team. I love the work we're doing here. And I think, any customer that would work with Air Products would be lucky too.
Awesome. Well, thanks for everyone for joining today. So I think I'm going to turn it over to Fred for some of the questions that have been asked today.
Thank you, Tony and Emily, for a great presentation. We've received several questions throughout the program, so let's jump right in. And either one of both of you, please feel free to share your thoughts. The first question we have is, what's the most common model tunnel freezer you build?
Yeah, I can take that one. So we didn't speak a whole lot in depth on it, but there was a picture on one of the slides of it. So the most common machine that we build and deploy here in the US is our Model IQ tunnel. So this is a modular tunnel. They come in 10-foot sections. It has state-of-the-art controls, the latest and greatest Allen Bradley components. This is a tunnel that is really the workhorse tunnel here in the US. We do always keep a stock and an inventory of these tunnels in case we have a customer need or something that comes up where we need to deploy a system quickly. So there's always stock, and it's a very robust and well enjoyed freezing platform.
Next question we have here says, I'm currently manufacturing shrimps. Currently, I'm operating in small scale, but I have a plan to manufacture more and do export. I have a plan to go with IQF, so is there any range of minimum or maximum production requirements to install a system?
So we could certainly help you with that. So the immersion freezer that we talked about is a great freezer that could be utilized for IQF product like shrimp. So as far as minimum production rates, I'd probably say 1,000 pounds an hour is probably the minimum we're talking about. But I think that's a conversation we can have, and we'd be happy to work with you. And like I mentioned, we do have a beta system that we're looking to deploy, so it could be an opportunity to work together. We've got our contact information here on the screen, so please feel free to reach out via email or give us a call, and we'd be happy to connect with you.
Next question we have is, how is your team structured?
Yeah, it's a good question. So our foods team specifically at Air Products is broken into a couple of different teams. So we have an AT team that we call it internally, an advanced technology team. That's really responsible for designing and building the next generation of equipment. We have a CT team, commercial technology, and that's broken out into a central team and a sub-regional based team. So we have folks all over North America that are, working directly with the sales organization to sign and maintain current customers. We have a marketing team, which Emily is a part of, that's designed, specifically to look at different marketing campaigns, brochures, trade shows that we attend. And then we have an engineering team that is really structured and designed to facilitate the build of our equipment and product line improvements.
Another question we have here says, want to know the OPEX comparison, mechanical versus cryogenic.
Yeah, that's a great question, right? And that's one that we definitely get asked quite a bit, right? I think, it's certainly maybe we could have a whole webinar just on that particular topic. That being said, I think, mechanical systems start to make sense economically when you get into that very high throughput range, right? Typically in that 6, 7, 8,000 pounds an hour type of range. If you're going to be a processor working in that type of production range, that's when you start to see the break-even point, I'd say, with mechanical systems. Mechanical system is going to cost quite a bit of capital on the upfront side of things, and that's really the difference, right? The cryogenic side is a little lower on the upfront capital, but it has that operating cost, and then mechanical, quite a bit of a heavy capital intensive on the front end, but then a little bit less, on the back end. So just an economics number to crunch, but we'd be happy to work with you and happy to chat it through if you want to reach out after.
I guess one question I kind of had is, how does a meat processor's investment in this equipment area intersect with their overall food safety and product quality assurance efforts?
Yeah, so product quality is really one of the things we hang our hat on with the cryogenic system. So when you flash freeze with cryogenics, we're working in such cold operating temperatures that the benefit is really, it all comes down to ice crystals. So when you freeze quickly, there's a lot of nucleation sites for ice crystals to start. And all those nucleation sites mean that we're going to result in very small ice crystals in that food product. Smaller ice crystals mean less damage to cell walls, less cell breakage, and therefore that when we defrost that product, you're not going to see that puddle of water or dehydration, just liquid seepage coming out of the product upon defrost. You're going to minimize that. You're going to have a much better tasting, texture, quality product when it's defrosted. So cryogenics is certainly an area where if you have a very high value added product, it's certainly the freezing method you want to look at.
Well, that's all the time we have for questions today. Please join me once again in thanking Tony and Emily for their presentation, as well as our sponsor, Air Products and Chemicals Incorporated. If you have any additional questions, please email webinars@bnpmedia.com. We're happy to help. When you exit the webinar, you'll be taken to a brief post-event survey. We'd appreciate you taking a moment to share your feedback, as it helps us to continue to improve our programs. Please visit www.provisioneronline.com for the archive of this presentation and information about upcoming events. We appreciate your time and hope you have found this webinar to be a valuable experience.